Hello and welcome to all students. In this lecture we learn about the ratio test and the root test, the test of convergence of a series. In the previous lecture we have studied the geometric series, convergent and divergent series, algebra of convergent series, test of convergence, alternating series, absolute convergence, and now in this lecture we learn about the ratio test and the root test. So first of all we define the ratio test and the root test. Now we give two more tools that are very useful in determining whether a given series is absolutely convergent or not, and these two tools are the ratio test and the root test. So first of all we study about the ratio test. So this test is, what is the test? We will write here: if limit n tends to infinity mod an plus 1 upon an is equal to L and it is strictly less than 1, then the series summation n equal to 1 to infinity is absolutely convergent and hence convergent. So see here, first statement of that ratio test says that if we have a series summation n equal to 1 to infinity, then we just find out the limit as n tends to infinity of the function mod an plus 1 upon an, it is equal to L less than 1. Then the series, just we find out the limit n tends to infinity mod an plus 1 upon an, and suppose that limit is equal to L, and if that value L is less than 1, then our conclusion is series summation an is absolutely convergent and hence it is convergent. Okay, so this is first statement of this ratio test. Second statement is, if limit n tends to infinity mod an plus 1 upon an is equal to L and it is greater than 1, or limit n tends to infinity mod an plus 1 upon an tends to infinity, then the series summation an is divergent. So this is second statement of this ratio test. If the limit of this ratio mod an plus 1 upon an is greater than 1 or it tends to infinity, then we say that the series summation an is divergent. And the third statement says that if the limit of that ratio mod an plus 1 upon an as n tends to infinity is equal to 1, then the ratio test is inconclusive, that is, no conclusion can be drawn about the convergence or divergence of the series summation an. If limit n tends to infinity mod an plus 1 upon an is equal to 1, in this case no conclusion can be drawn about the convergence and divergence of the series summation an. Now we see the root test, and the first statement of that root test is, the examples on ratio test we will solve afterwards. Now we study about the root test. The first statement is, if the limit n tends to infinity root mod an is equal to L and that limit is L is less than 1, then the series summation n equal to 1 to infinity is absolutely convergent and hence convergent. So similar to the ratio test, the first statement of the root test is stated here. If the limit n tends to infinity mod square root mod an is equal to L, and if that limit is strictly less than 1, then our conclusion is series summation an is absolutely convergent and hence we say that this series is convergent. Second statement of that root test is, if the limit n tends to infinity square root mod an is equal to L, and if that limit L is greater than 1, or limit n tends to infinity square root mod an tends to infinity, then the series summation an n equal to 1 to infinity is absolutely convergent. And so second statement is, if the limit square root mod an is greater than 1 or tends to infinity, then the series summation an is divergent. That is our second statement. And third statement is, if limit n tends to infinity square root mod an is equal to 1, in this case the root test is inconclusive. The root test is inconclusive. In this case we cannot make any conclusion about the convergence and divergence of this series. So one important remark is, the root test is convenient to apply when the nth powers occurs. Let us write some examples. Example number 1. Test the convergence of the series summation n runs from 1 to infinity n square upon 2 raised to n, and we write the solution for this example. We have to test the convergence of this series summation n square upon 2 raised to n equal to 1 to infinity. So solution, from the given series an means nth term of this series is n square upon 2 raised to n. Now we take, so here nth power occurs, therefore we use nth root test to check the convergence and divergence of this series. Now consider nth root of an, it is equal to nth root of n square upon 2 raised to n, and it is equal to, separate denominator and numerator, nth root of n square upon nth root of 2 raised to n. So if we simplify this, it is equal to nth root of n its square divided by 2. Now we consider the limit n tends to infinity nth root of an is equal to limit n tends to infinity. So nth root of an that we have calculated above, we put here nth root of n square divided by 2, it is equal to limit n tends to infinity. Separate this limit, the limit of 2 is 2, and the limit of numerator we write here limit n tends to infinity nth root of square root n and its square. So we know that nth root of n is 1 as n tends to infinity, therefore limit n tends to infinity nth root of n is equal to 1/2, and that 1/2 is strictly less than 1. So in this case our conclusion is that the given series is absolutely convergent and hence converges to, and hence convergent. Okay, by the nth root test we get the given series is convergent. Let us take example number 2. Test the convergence of the series. Series is given here, summation 2 raised to n divided by n square, n runs from 1 to infinity. So this series is exactly reverse of the above series. So nth term is reciprocal of the nth term of above series. Okay, from the given series an is equal to 2 raised to n divided by n square. Now take nth root of an, and we see here nth root of an is equal to 2 divided by nth root of n its square. So again we have nth root of n is equal to 1 as n tends to infinity. Therefore limit n tends to infinity nth root of an is equal to 2, and that 2 is greater than 1. Therefore by the nth root test we get the given series is divergent. So in this way we can solve the problems by using ratio test and root test. So let us we write some examples for practice. So these are the some examples for your practice. First example is summation. Summation or series n equal to 1 to infinity n raised to root 2 divided by 2 raised to n. Second example is summation n equal to 1 to infinity n raised to 10 divided by 10 raised to n. Third example is series 1 minus 3 by n raised to n. Next example is series 1 upon n minus 1 upon n square. And next example is series ln upon n cube. And last example is summation ln upon n runs from 1 to infinity. So these are the examples based on these two root test and ratio test. Try to solve these examples at home. Okay, now we stop here. Thank you very much.